often different than the forest. A lot of people have pictures of trees in the forest, and we have pictures of trees in the city, and how trees grow actually where people live. And it's a huge treatment difference and management difference about trees where people live. And I know in Montana, you have both a lot of rural, populated, and wildlands. And I don't like to use the word urban forestry a lot because unless you're in a city, you don't consider yourself urban. So I'll talk a lot about trees where people live, and meaning what some people refer to as urban forestry. So about me, I've been working with managing trees since I got out of college in 1977. I've worked for 4 cities, 3 private companies, 1 nonprofit, and now consulting with 3 other partners. But I've been consulting since I started work out of college in 1978, when I went to work for a second city as part-time. I currently serve on both the International Society of Arboriculture and California Urban Forest Council boards as directors. I'm a past president of the Western Chapter, ASCA, California Arborist Association, San Mateo Arboretum Society, and I've been on past boards of the Society of Municipal Arborists, and I served as the board a member and the chair of the California Urban Forest Advisory Council that advised CAL FIRE, which used to be called the California Department of Trees and Forestry Protection, on their policies and practices. I've retired ski patroller from Sugar Bowl. I enjoy hiking, tennis, golf, and camping with the family. And I was a public works superintendent in the city of Redwood City for 15 years in the right-of-way maintenance division. And we had streets, sidewalks, traffic signals, street lights, parking meters, paint and sign, and trees. And I started Redwood City Sidewalk Repair Program in 1984 and worked with that all the way until I retired from the city in 2007. So what I'll be talking about is a combination of my personal experience and all I've learned from a lot of mentors and coworkers and professional organizations. And I appreciate you all being here because some of the things people are doing with sidewalks now, I started doing in 1985 and 86, talking about it, presenting about it at American Public Works Association and all kinds of landscapes and all kinds of tree conferences. And again, these are the kind of trees, the kind of streets and trees I believe most people want to live with in their communities. So for opening thoughts, that as arborists, often we're triage responders. We get called in to try and fix a difficult situation. Usually the trees cause damage, sometimes the trees failed, and it's very high difficulty. And wouldn't it be great if we were in the planning process and could help people that don't understand trees and how trees grow where people live, and identify the worthwhile trees on the property, protect the appropriate trees before the construction begins, and see if more trees can live and continue with our canopies. You know, how many of you have seen failing landscapes? In order for a project to get approved before most city council these days, they have to have, and county board of supervisors, they have to have trees included in the project. Unfortunately, there's a thing called Photoshop, and you can Photoshop a redwood in a 3-foot wide planting strip. And the trees will never grow there. They'll get too big for the inadequate planting space, and they'll either die, or worse yet, they'll damage something and cut down early because, oh, those sidewalks and curbs are way more valuable than these ridiculous trees that can be replaced with another tree. There's no long-term maintenance plan on most landscape architecture designs I've ever seen. And most landscape architect designs are designed for the trees at the time of planting. And if you have a bare site and you put your trees on 30 or 40-foot centers where they should be at maturity, it's going to look like a desert. So it's typical that landscape architects will overplant. And there's nothing wrong with overplanting. But if they don't give us the proposed spacing of those trees and the spacing of the plants and how to change the irrigation so that we can work with a smaller number of trees over a larger area, then the design is really inadequate. And unfortunately, nobody requires, nobody I'm aware of requires landscape architects to include a long-term maintenance plan with their designs. And I'm wondering how many landscape architects have gone out 25, 30 years later to look at their design and seen that their trees on 10-foot center have not been thinned, or they've seen that their trees on 10-foot centers now on 30-foot centers and be surprised. This is a typical reconstruction project in Sacramento. Fortunately, it's a London plane. It does very well with with root pruning, but you can see where they had to root prune down to at least 18 inches to put the curb and gutter in, and probably deeper where that catch basin is, right by the tire on the trailer. So here's what I want to talk about today, and hopefully this will be beneficial to you. I talked a lot first to find out, what you wanted to, with Fred, what you wanted to go over, and make sure that I'm doing what you want to hear, not what just I want to tell you. As I could talk for a long time, but if it doesn't do you any good, I'm just going to send people to sleep or to the coffee pot. So what I want to do is, there are a thing called ANSI A300 tree management standards, and I've been fortunate to serve as the alternate, the rep, and now the alternate for the Society of Municipal Arborists on this committee, where we actually write the industry standards. And in 2011, I was the chair of the committee that wrote Part 5, or rewrote Part 5. And now it's been again rewritten in 2019. Again, every time we write it, it gets upgraded, and they've done a great job in shortening what I had. It was a lot wordier, but it was a big change from what it was previously. The idea is to write quality specifications that actually work. And the reason that the way a quality specification works is that I, as a worker, could not go in and do something different than what you want done following the specifications and have the outcome come out differently. So it's easier to see with pruning if I want the tree to look like a natural tree and not have a lot of large branches taken out. And I write the specs and allow you to come in and cut off all the branches for whatever reason, whether they're dead, dying, diseased, crossing, and gives you permission to cut off branches you shouldn't be cutting off, then those specifications don't work. We're talking about construction. If we're not creating the specifications that do tree preservation, and a lot of times people want to use the drip line or a certain measurement so many times the trunk diameter. And for all the arborists out there, if that's how we make our decisions, we don't need you. We just need a calculator and a tape measure. Where the arborists come in is to say, gee, we have to encroach a little bit on this tree. How can we do it? And how can we protect the rest of the soil and the rest of the root system so this tree can actually survive and still be living on the site once the construction is done? Once we have good specifications, then we have to have quality inspections that actually make sure the specifications are being followed. And we have to do good quality assessment of the trees, both before, during, and after some of these inspections. Make sure that we pick the right trees to preserve, and then during the preservation process and the protection process, the trees are still growing. Then when we get done, that the trees have survived the process. And a lot of times we have to have specific protection needs for trees. It's not just put a fence up and that's it. We do a lot of pier and beam construction where they want to get real close to the trunks of some trees. And you can do that because if you're careful where you're drilling the pier, it's 12 to 18 inch diameter hole under a very large root system, and it shouldn't cause any problems. And if you have the ability to know that if you do hit a root in a drilling and you can move the hole over a little bit because the design allows a little bit of spacing, then we can put that structure right next to the trees, or in areas where the trees we wouldn't be able to build, or we'd have to remove the trees if we didn't do that. And then we want to look at follow-up care, because how we take care of the trees after anything we do is important. Again, there's standards and best practices for that. So if you're ready, here we go. We want to write our specifications based on ANSI A300 standards and the ISA BMPs. That's what gives us the support. If you're in public works or you're in building department, you've got the public works standard specifications for most cities, states, counties. They have the state of California has a big green book. I'm sure the state of Montana has a big standards book. And we have the uniform building codes that most building inspectors use. But they don't think that trees have standards because they don't consider trees assets so what happens is that the trees just get looked at like a picture on the wall. We'll just take it out and replace it with another picture. But you're not replacing a Rembrandt with a postcard. When you do what you're, in most cases, unless you're in a museum and you're taking a picture off the wall. So we have to look at, we have a Rembrandt, you want to replace it with a postcard when you cut down a mature tree and replace it with a newly planted tree. We can look at sections Part 5 of the ANSI A300 standards and the ISA BMPs on construction management and see how things are intended to be used. Then we want to use steps to implement good construction management following these standards and BMPs. And if we create a tree protection plan and it's not on the plan documents that are used in the construction, then they don't exist because the people operating the equipment, the people on the site don't know that there was supposed to be a fence there, don't know that they can't excavate, don't know that they have to root prune before they rip the roots out of the ground and tear them back towards the tree beyond the edge trench where they're working. On sidewalks, you know, they don't know that they're not supposed to rip all the roots out to put the sidewalks in. Another question we have for all the city engineers and county engineers is, why do sidewalks have to be concrete? There are many other opportunities that a concrete sidewalk put next to a tree will get broken, and replaced with a concrete sidewalk that will get broken is insanity, doing something over and over again, expecting a different result. So we want to implement these construction management plans and ideas and do what we can to try and retain the trees. Then we have to have on-site observations, reasonable inspection protocols, and follow the specifications to make sure what we planned actually gets built properly. This is a tree in Weaverville, California. I was called in by the community because Caltrans was going to kill all their large trees. And this was done before I got there. And you can see there's a board right here. Let's see if I can get over there. There we go. There's a board right here that was the form. And it was so tight to the tree and the curb that they couldn't pull the form out after the construction was done. These decorative bricks are only 3.5 inches deep or less, and if they weren't put over 4 inches of concrete, that's a nice decorative band that's expendable because it's not part of the full construction. But all the other concrete around the tree is permanent concrete that's likely to get damaged by a tree that's large. Oh, excuse me here, I'm working between, there we go. Okay, so the thing I would really like you to pay attention to is that trees are infrastructure. They're dynamic infrastructure, different than any other infrastructure people deal with. Everything else we build it and it stays the same. Trees change from the first day they're planted and continue to grow. And thank goodness they do, or they wouldn't grow and we wouldn't have trees. They would just be the same stick size we planted the day we planted it. Or if we transplant a really large tree with a 20 or 25-foot root ball, how do you put that in the ground in most places where people live, where you've got water, sewer, sometimes underground electricity, cable TV, and things like that? So we really want to work these dynamic infrastructures into static infrastructures because they are completely different. They have to be managed differently. However, most engineers I work with don't understand this, and we have to really do a good job to explain to them how they have to consider it differently. The designs and the space given to trees have to consider the mature size of the tree, not the tree at the time of placement, to avoid infrastructure conflicts and either expensive damage to the adjacent infrastructure or premature removal of the tree, which is most of our arborist concerns. And when we start going into the value of trees, you'll see that size really does matter, and removing large trees is a large impact on the value and things that people do. Trees increase in value as they grow until senescence. Since we're considering trees as assets, every asset requires preventive maintenance, and most assets have a point in time where they're no longer valuable and their life has exceeded their value and it's time to be transitioned out. There are things we can do with trees, with ancient trees and things to keep them around, but they will definitely be a different tree than they were when they were growing and had a much larger crown. And for those of you that have cities, if you've probably heard of a heat island effect, and you can see in the center of the picture, the point, that's over the city where everything is covered. There's very little soil, open soil. There's very little vegetation, mostly buildings, streets, and pavement and things like that they absorb the heat from the sun, and it lasts a lot longer. So it's anywhere from 3 to 6 degrees, sometimes 8 degrees hotter, and it lasts longer during the daytime than it does into the evening. So in places, especially like Arizona, where they're really hot, the evenings retain the heat hotter, and so there's a higher demand on air conditioning and things. And trees do mitigate temperature. So trees being planted in some of these overbuilt areas with all kinds of buildings and hardscape, that trees can reduce the temperature quite significantly. And so this talks about a site in Davis, California, where Dr. Greg McPherson, who used to be the head scientist at the Southwest a research station for the Forest Service, and he's the one that developed Streets, one of the greatest iTree tools we ever had in urban forestry. Was working on parking lots. And he's talking about how we can change the temperature of the cars that park out there in the sun, especially in California, where it gets really warmer with the sun. And these are two different site designs. The upper right, where it was the previous design, and the lower left, where they put the trees in there to try and shade the parking lots and manage stormwater interception, the air quality, as well as the appearance of the site. So I was able to do some research on Montana's tree benefits. And for those of you in Montana, you have an excellent guide here. I left the link there, and I'm hoping that Fred will be able to share the PowerPoint with anybody that needs it, so you can go in there and take some of my slides and take some of the information and use it to support some of the things that we're doing to try and help improve our communities. So you have the Urban Forest Resource Analysis of the state of Montana was done in 2017. And it's going to talk about the benefits of trees for the next few slides. I'm not going to read them to you. I'll just read the main one, aesthetics, and then we'll go to the next one. And there's the link on the top of where this was. And then you have human health. You know, we don't use the human health and the reducing of stress with trees enough. And for those of you that have any kind of personal physical challenges, like I had shingles from stress, and other people that have had other diseases and personal problems, and stress is huge, and trees help reduce it. It's a great way to have a healthier life. Water quality, intercepting stormwater. I was working with Dr. Zhang about some stormwater presentations in the Pacific Northwest and a few other places. He's not an arborist, but he's really strong on what water quality is, and he knows that trees can help intercept that stormwater and save a lot of money versus building pipes and things like that, and creating more open space, open soil, so stormwater can actually infiltrate into the soil. Air quality. Breathing is kind of one of those important things we all have to do. And in Sacramento, I worked at the Tree Foundation in 2007 through 2009, and we were able to get air quality into the state air quality plan only by planting trees that have less BVOCs, biological volatile organic compounds, that the trees emit. And there was one scientist I worked with there who said even the worst emitters, which California's valley oak is one of, have a net gain in air quality, even though they're a high emitter, from all the other benefits and things trees do for air quality. We have carbon sequestration. Carbon's a big deal right now. People are looking at it. And also at the bottom of these slides, there's some values that the state of Montana gets from all these things, from your trees in the state. For commercial businesses, Dr. Kathleen Wolf in Washington, she did some studies showing that you can stimulate business by having trees where people can park in the shade and actually walk and shop in shaded environments. They'll spend 9 to 12% more. Property values can go anywhere. I've seen 1 to 7 to 15%, a couple cases 20%. I put the range of 5 to 20, I probably should say 1 to 20. I went to my city manager in Redwood City and said, Ed, look at these studies on the value of property values based on trees. We have this great urban forest, we're doing all this investment here. Maybe you could help me increase my budget a little bit so we can continue to grow better trees and continue to get higher property values so the city gets higher property taxes. And he sat back, looked at me, smiled, scratched his beard. He said, very creative, but no. But it really works. And I think we have to do this in cases that we have to make nice places to live and great places for people to live. And trees are part of that. And energy conservation. It's a big one. Sacramento Tree Foundation is funded by SMUD, the Sacramento Municipal Utility District, and they fund us, they fund their tree planting based on the amount of shade and the reduction in electricity for air conditioning that people have to do throughout the year. And 30 years ago, instead of building a new plant for multi-million dollars, they started spending about $1 to $2 million a year planting trees with the need to do that. And you can see the air quality savings, almost $2 million in Montana. So trees have return on investment in Montana. For every dollar invested, the state receives somehow $4.41 in benefits, and through energy savings, all the different things we just talked about. The coolest things about trees are they multitask. people plant them because they're pretty. They plant them to shade the house. They plant them because they have to for a requirement from the city council. They plant them because they want to screen their neighbors. They plant them for air quality, stormwater, whatever. But we get all those other benefits that come with it. So those several slides of benefits they all come with the trees when they get planted. And trees have something similar to humans as we go through the COVID-19 right now, invasive threats and management. And many of you may have heard of emerald ash borer. I have many friends in urban forestry around the country and that have been managing emerald ash borer. And it just amazes me how this is one insect, except for Denver, where it jumped probably through firewood. You can watch it move. You can watch it flow across the country, and you can start planning for it. And with a threat like emerald ash borer, you have two choices. You treat your tree or you cut it down. And if there's trees we want to save that we have in our communities, we're going to look at an inventory of them and treat those trees we want to save as we watch the bug get closer. But if we wait till we find the bug in our community, it's already been there for 2 years and our options are all gone. Now it's how to remove trees and maybe treat the last ones that haven't died yet. It's really too bad that we can't be more foresighted in our management of some of these invasive threats. And with especially emerald ash borer, it's a very manageable project. In 2008, I was working with John, I think of his last name, from Ontario, Canada. And he said, we're doing all these different things and nobody knows about. All they're talking about is removing trees. So we set up a webinar through Society of Municipal Arborists so we could educate everybody with what John was doing in Oakville, Canada. And it's been very helpful. And those the kind of things is sharing, and things like this where we're sharing information are going to help people. So in Montana, ash is more than 40% of all the publicly owned trees in 18 communities. And of 61 communities, only 11 have 10% or less. So when you start looking at tree management, diversity is very huge. So iTree is a computer program that's free, developed by the Forest Service with several partners. Davey Tree has been very big with that, and they have a person dedicated to it that works on things. They've created a whole bunch of new options with iTree so it's itreetools.org is the website. And this one thing streets that was done in probably 2005 by Greg McPherson. It gave us the replacement cost of our urban forest. So in Green Bay, they were getting $6.14 annual benefits for every dollar they invested. Milwaukee, with 3 million trees, valued at $1.43 billion replacement costs, getting $12.7 million in benefits a year. Orlando, Florida, the urban forest is valued at $181 million with $1.87 return for every dollar spent. A smaller city like Bowling Green, Ohio, the trees are worth $4.16 million and they're getting $2.58 for every dollar invested. When we get to Montana, here's from your list. There were 61 trees on your list. I took 7. Some I knew were going to be here. Some places I've been to. And you can see that in Montana, the average cost per tree ranges anywhere from, about $1,100 or about a little over $1,000 to $1,300 based on the size of the trees and the benefits they provide. So as a really rough estimate, if you knew how many trees you had in your city and you multiplied it by, say, $1,050 or $1,100, you'd have just a rough understanding of what your urban forest is worth in replacement cost. It's not just saying we'll cut them all down and plant new trees. No, to replace them in kind with what you have, that's the value of it. And like in Bozeman, when you've got $11 million, or Kalispell, $10 million, now you're starting Missoula, $22 million. You're starting to equal the cost of the concrete sidewalks. You're starting to equal the cost of traffic signals, other public work investments that we have in the city if we had to replace those in kind. And we start looking at trees that way, they now have a value that's different from just they're pretty to look at. And we start looking at the return on investments we're getting from anywhere from $1.50 to $4.50 per dollar invested. Now trees are one of the few assets we have in a community that are actually paying for themselves over time. When you look at the really big tree inventories, such as Chicago, Minneapolis, and Portland, we're talking high millions to billions of dollars of value and millions of dollars in benefits coming back. And it gives a lot of credence and support to managing our urban trees. Now, the benefits of trees come from the leaves. through the canopy cover, the shade, the air quality. And that's why you can't just replace a big tree with a bunch of small trees. Even if you had a tree that had say a 50-foot diameter radius, and you put a bunch of small trees on the ground to meet that 50-foot radius, lose the whole height and breadth that you get from those leaves. And so size really does matter with trees. And crowns provide more benefits. And that's why pruning is so important. If you consider trees compared to General Motors or Chrysler or Ford, and you say, okay, all their workers are our leaves. If I cut 33% of the leaves off the tree, I just fired my night crew. If I take 66% of the leaves off the tree, I fired both my swing shift and my night crew. And if I top the tree or hat rack it, I've fired all my workers, day, swing, and night shift. Who's going to build my cars? Since the leaves of the worker bees that create the sugars and do the actual wood production, who's going to make the wood for the tree? So how do trees react? They don't go to the union hall and hire people. They just start sprouting leaves out from every bud that's on the branch or on the stem, and they come out very, very disorganized, and they just come out wherever they are. And so the maintenance we have to do to fix that is way higher. And so knowing that we can grow these large trees and pruning them well and keeping as many leaves as we can, that's where we're getting our benefits, and that's where we're going to have the trees provide the most resources for our communities. So I want to go into how to inspect trees during construction. So I had a meeting with our building inspectors in Redwood City. Now, again, I was very fortunate. As the public works superintendent, I was 2 steps below the city manager. I had my director and the city manager. The city engineer was 3 steps below because he had the public works director and then a supervising engineer and then the city engineer. The building inspector and I were on the same level. He would report directly to the community development director. So I could have meetings with these folks, fortunately, and I'd sit with the building inspectors and go, you know, okay, if you know what a fence looks like, raise your hand. Of course, they all raise their hands. So when you see a plan that has a fence on it and the fence isn't there, you don't just close your eyes and walk away. You call me, okay? And so it's like, I was with one building inspector and the concrete truck drove across the concrete sidewalk and broke it. And then they were putting the sidewalk in for sidewalk repair fix because it was broken. And fortunately, I observed, I said, no, before you get your occupancy permit, you're fixing the sidewalk because you broke it during the construction process. As a building inspector, your job is not to be nice. A lot of city officials and city charged people don't want to tell people no. Well, that's our job as a municipal employee. Tell people yes and no at the right times for the right reasons, and not flip coins and make, you know, any bad judgments, make good judgments following our laws. And so when I denied permits on our tree preservation ordinance and the Parks and Rec Commission overturned me and approved the permit, people said, "Are you upset?" I go, "No, I'm not upset. They have their standards they want to follow and their politics that I don't have to follow. I can follow the rules." Now, if I'm in front of them every week because they're overturning my permits, then it's not my problem. It's not their problem. It's the ordinance problem. We'd have to look at that ordinance and make sure that it's written right. But as long as they're only overturning 2 or 3 a year, and I'm getting 97 or maybe even 99% of my permits going through the way I want them to. So if I'm doing 600 permits, they overturn 3, and that's 0.5%. We're doing pretty good with our ordinance. So one of the most important things about when we do work as arborists, it's the assignment, understanding what exactly we're here to do. And that's the second bullet from the bottom. And then the next piece of that then is, once you know the assignment is, make those decisions and get tree protection specifications in place, and then look at the different construction techniques that can be used to make that work. This is a site that had no protection. You can see they've stacked stuff around the base of the trees. They're compacting the soil in the drip line of the tree. And when we do tree protection, we're not protecting the trunk, we're protecting the soil and the root system. If all the soil we have is compacted, when water comes down, it's just going to run off and flow away. So, and here's a site that has protected trees. It's got fencing, and in the area that's really critical to the tree, they're not doing any construction. They're doing their damage outside that area. Inspection protocols can actually be based on our risk assessment protocols, where we have level 1, 2, and 3 inspections. Typically, we're doing a level 2 inspection. Level 1 is a limited viewpoint. We might be driving by, we might be standing on a porch looking out. We're looking for something very specific. storm damage, flagging from Dutch elm disease, flagging from oak wilt, things like that, or you can see broken branches as you drive down the street after a storm. Those are very limited. And then what those lead to is a level 2 where we're doing a 360-degree visual, walking around the tree. We might have to do some light excavation because if I'm supposed to look at the trunk flare and I can't see it, I may have to do a light excavation. It's not a full root crown excavation. That will be a level 3. We may have decay that we're probing cavities to see how deep they are. We're sounding with a mallet to see if there's decay. And we're checking all the visible tree parts, looking for the attachments and possible decay. And level 3 is advanced, where we have to get more information. It could be a root crown excavation. It could be an aerial inspection. It could be tomography, resistance drilling, several things like that that are going to give us more information about what's happening. So our typical inspection is going to be level 2. So what are the considerations for tree conservation and those conditions for conservation? The tree should be healthy. It should have reasonable vigor. It should have good quality leaves, buds. A lot of times we're deciduous trees, we're looking at trees in the wintertime. We have to be able to identify their buds. The branch foliage density and the bud density and the location of the foliage on the branches. Twig elongation, are they growing from year to year? Presence of insects or diseases. Decay cavities would compromise the actual cylinder. Any decay does not mean the tree has to be removed. We have very few flag rods. There's a bunch of flag poles. So if that wall thickness is strong enough, we can have some hollowness to our trees and still make it a very stable tree and low enough risk to continue to grow. I have 2 trees in my backyard that have ram's horns on them, which are the areas decayed and slowly callousing over. And we look at it from the vertical view, it looks like ram's horns. And I've been here 13 years and those trees are still existing fine in my backyard. We look at the trunk flare, root crown quality. A lot of people, they have a trunk flare, root flare. When I use my descriptions, I try and say something simple that I'm looking at. So I call it a trunk flare because it's supposed to be above the ground, and so it should be part of the trunk. If it was a root flare, roots are below the ground, so then you can bury the trunk flare and get away with it. I want my trunk flares visible. Leans or severe end weights. We want to make sure that it's sometimes leans and end weights can be pruned to mitigate. And then structure and ability to prune, reduce for clearance or for size for the construction that we have. All these things that we consider tree for conservation or preservation during construction or during a project we're looking at. Now, when I was in Redwood City, I looked at, we called it the tree preservation and sidewalk repair program, but I called it tree removal avoidance. Simply avoiding or delaying removal is not preservation. Circling a tree on a plan and saying we're saving it is not protecting it, it's not preservation. Tree preservation is when you have the area and space and you can work around the tree, and simple things like a bicycle grown into it or concrete around it. The concrete's far enough away that if we have to replace it, we can do so without destroying the tree. Tree preservation, on the other hand, we do as much as possible to avoid any impacts or changes to the tree's growing environment. We don't cut roots if we don't have to. We don't compact the soil over the roots we're trying to keep. We don't impact drainage, so it either floods the base of the tree or takes groundwater away from the tree it was used to getting. And we look at our grade changes and don't bury the trunks of the trees. We can bury some of the roots if we do some mitigation and are careful how we do it. And we protect the trees from the impacts of construction or site changes very carefully. This is removal avoidance. So we are root pruning trees 3 feet from the trunk. That was the distance we were able to come up with in Redwood City that worked. There were studies done in the early 80s that said there was sinker roots, downward growing roots in 3 and 5 feet of the trunk. I couldn't get beyond 5 feet. I couldn't get to 5 feet, but I get 3 feet. So we made 3 feet our standard. The picture on the right, we had root pruned this tree. It was very high storm where we lost a lot of trees, and trees that we only had 15 failures. 10 of those were root pruned, and we had 440 service requests, and some trees had 20-inch diameter stems broken off like a toothpick. That's how severe the winds were. This tree on the right, you can see the entire planting area over 20 feet long, completely uprooted when the tree failed. And so we were pretty close to not losing it, but we lost that one. So when we look at tree removal avoidance, is how much root removal can I cause without killing the tree or having it fail unexpectedly? How much impact can I do to the tree without killing it, right? That's not preservation. That's avoiding the removal and hopefully getting it right. And we got it right over 98% of the time, almost 99% of the time in Redwood City. Over the years of doing almost 5,000 root pruning, we had about 172 trees that failed. And then we always have this. We could have the Pinus celtaurus or the cell palm that can substitute for trees for us. We never have to worry about their root systems growing, and we actually get a return on investment, but we don't get all the other benefits that trees provide except little shade. So next I'm going to talk about Part 5 A300 and the BMPs. And so here's the ways trees are damaged during construction. The most secretive ones, I guess, are the first two, the root cutting or damage and soil compaction, with soil compaction being the biggest one, because we're driving over the soil and we haven't done anything to the tree, but we've cut off the root systems from oxygen and water percolation. The easy ones to see are the injury to the trunk, crown, and major roots. And then a lot of times when we clear an area out, we get heat damage, both from the sun exposing trees that hadn't been there before to new pavement and things like that, causing reflection. And sometimes we have equipment like paving equipment and trucks that park under the trees, and their exhaust damages some of the branches. We have chemical damage from all different chemicals used during construction, and sometimes they get spilled on the site. That's why when you have tree protection, and no stored stuff is supposed to be under the tree. And then we have trunk flare or root collar damage, usually from grade changes. These are the books, if you haven't seen them. Part 5 update in 2019 on the left, and Managing Trees During Construction, second edition, the BMP on the right. And usually the standard comes out first and the BMP comes out second. Often there is some changes to this because the ISA's BMPs are international and the A300 standards are US. So sometimes there might be a little bit of difference. You have to be aware of that when you're using those documents. The intent of the A300 is to provide the industry standards for writing and developing specifications, in this case, for the management of trees and shrubs during planning, site development, and construction. And then for the use, it sets the limits and descriptions for work. And it creates the box we work from. So if you were just to say, I use pruning because it's the easiest one. If you were just to say prune trees to A300 standards, well, pruning has 5 systems in there: natural, pollarding, espalier, bleaching. And so you give me the permission to choose what I want out of that standard to use and still be in accordance with the standards. That's why I said earlier, we have to write our specifications so they actually allow people to to work within what they're doing. And here's this example of, a construction site. Look at the tree. Now, if that tree had been removed prior to the construction, it would have been a lot cheaper to take down. And somebody thought they were saving it by building right next to it. We want to try and standardize trees management during the construction process without dictating every step. So all development situations are probably not the same. So the approach to managing trees during construction, it's like pruning. There's 3 ways to remove a branch: branch removal cut, heading cut, and reduction cut. How we use those cuts and where we make them, that's where the strategies and the arborist comes in. And so we use those, doing the correct things right, all the different individual things to protect the trees. We use them right, many in different ways, and they may not always apply to the same situation. And I hope that helps people out. It's just not a list and a bunch of check boxes. We actually have to do some thinking and some creative work sometimes to save some of these trees and to allow the trees to continue to grow during our projects. So when you compare again the standards to the BMPs, A300 is American. It was developed for writing specifications. The BMPs are the how-tos. They don't have a should or a shall that the specifications have. The specification says should. That's what we're supposed to be doing. Shall is what we should be doing. I'm sorry. Shall is what we're supposed to be doing. Should is what we should be doing and may vary from it for different situations. And like every time I root prune trees for sidewalks, those were exceptions to the standards. And I had to say, these are exceptions. Here's why I'm doing it and how I'm doing it. And I understand it's an exception. So I'm not following the standards, but I'm not necessarily violating the standards. I'm just making an exception to the standards. And the BMPs, they try and give us the how-tos on how to do it. But again, we can have things that are exceptions to the BMPs and make it work, because not everybody can cover every situation every time we write something up. That's hopefully where the arborist comes in. This is a brand new building. They retained all these large trees. Can you imagine what the appearance of this thing would have been if we planted 3 new trees where these 3 trees are growing? So the steps to using our all standards, in this case, part 5, is we start with having an objective. What are we doing on the site? Why are we doing it? Usually it's because we're going to protect trees because the owner wants them, the city, county, state requires them, or we have to meet a preservation standard, or the person who owns the property wants to keep the trees. A lot of times the person doing the work doesn't care because they're going to do the work and leave the site. And so we're there to protect the owner, protect the city and the residents of the community that are there to benefit from those trees. Because after the developer is gone, the trees are going to live hopefully for decades after, in some cases, maybe a century. The components and steps of the process to meet the objective are established. And we do that through creating a plan and then laying out the specifications and the inspection protocols and everything we need to do to make it happen. And then the specifications are written for achieving the objective. In my pruning talks, I use the example when I go to a barber shop, the guy's got a picture on the wall with 28 different ways my hair can look when I get out. I point to number 13, he makes my hair look like number 13. The women go in, they've got these books of supermodel haircuts. They pick to the hairstyle they want. When they leave, they look like the supermodel they wanted to, at least from their head. So the idea is we don't do that with trees, and we need to do that more. So maybe we take photographs and we do some, drawing on the photographs what the trees are going to look like when we're done. When we're doing development, we're going to show where the tree can be built next to and what the site has to look like around the tree. Again, these are construction sites where we have tree preservation in place, and depending on if it's a property line or if we have more access, we take as much space as we can, and then we can't get to the drip line. That's where the arborist comes in to figure out what we can do. The objective of the process, so the flow of the process, that's the objective of using the specifications. And part of the specification is the objectives, why we're doing the work. What's that scope of work? Then the planning and phase and resource evaluation. We get to the site first and we say, what are the trees on the site? Which ones are worth saving? Which ones aren't? Some cases you can do a mirror image of a house and flip the garage from the right side to the left side, keep the floor plan the same except for that, and save a bunch of trees and remove a bunch of trees that make more sense for the site. And then you have the design phase, which takes that into consideration and does it. Then we have the pre-construction phase where we create the specifications that are going to make that construction work. And then we have the construction phase where it's all implemented on the site. And then one of the things I noticed when we were back in 2011 is we have great developers that keep the fences up the whole time. And then the landscapers come in and they trench right next to the tree that the developer kept the site clear from. So we actually have to have a landscape phase and a landscape plan and landscape tree protections different from construction protections, because we're telling people to work closer to the trees than they were during the construction phase. And then we have a post-construction phase to analyze what's happening and hopefully keep the trees growing. And you can look at trees in many different ways. Nearby, try and find out what's wrong, and then from the population phase. But again, we can't just say we're going to develop things in compliance with A300, because you wouldn't tell somebody develop your thing with the engineering standards, because engineering standards have concrete, asphalt, all kinds of different areas that they cover. And so the idea is to take the standards and from those create our specifications. Again, they're performance standards, not specifications. And each situation will be different enough that the specific details are needed. So when we're doing construction, a lot of times we'll be trenching outside the fence, and we do root pruning on this side of the fence closest to the tree, and then we can excavate the roots out from that point away from the tree. In California, you have a lot of municipal ordinances they've really been a boon for consulting arborists and arborists. But each agency has their own ordinances, so you have to know the rules, the applicable rules, and you have to know the different definitions and requirements. And some of the ordinances require tree protection zones marked on the trees. And you can see it, not only does this have the fence up, it has a sign on it. And we do as much as we can, we put those in place. The tree protection plan is a specific plan to protect the tree. And it starts from the clearing and grubbing stage and demolition and construction, landscape and hardscape. If somebody goes in and grades the site and then asks us to do a tree protection plan, they may have already destroyed the soil and compacted it before we even get on the site. And so the plan needs to meet the objectives of development, community, and the owners. The plan, it's for the physical protection of the branches, trunk, and roots and soil. If you call it a soil protection plan, a lot of people might understand that better in some cases. Because what's the most difficult thing to mitigate? The soil. Once it gets compacted, it's really hard to decompact. So the arborist writes the specifications, but we're probably not the person implementing those recommendations or those specifications. So we have to, it's a delicate role to oversee the specifications, observe compliance, while the developer might be paying us. But we have to have our integrity, because that's something that nobody can take away, our integrity. We monitor tree health and protection zone barriers, make sure the fences are in place, and these be done throughout the project. And a lot of times it's random inspections, so you don't know you're coming, so they can't set it up the hour before you get there. Or if I'm showing up to the site, I don't want them to know I'm coming, so I can actually see what's going on. And then I can make sure that they're actually doing what they're supposed to be doing. And we have to report in written records of what's happening. So here's a site where you can see the orange fence, and they had to do some pruning to avoid breakage of branches by equipment. And even though this is a small island, this is along a freeway, these trees were way better protected than if they didn't have anything here and cut the grade right down to the trunk of the tree. Being native trees on the irrigated site, there was not much root pruning that did take place on the outer edges of this island. You know, there's a risk to perfection. If everything was perfect, then most trees would be either removed or there would be no development, because you're rarely going to get all the way out to the drip line all the time. You're rarely going to get everything that tree would need for perfection. But we can do things that do protect the trees inside of perfection and retain a lot of trees. We did it with sidewalk repair, root pruning. We've done it with all kinds of different construction projects I've been involved in. And when we put concrete sidewalks next to tree roots, this is what you can expect to happen. There's a perfect area where the sun heats the concrete, water condensates underneath it. There's a little seam there where the little young roots can get started. And when the roots grow, they turn big and then they cause their problems. So we want to build without perfection. We want to offer the opinions and options for tree preservation, management, alternative construction techniques, reducing risks. And we want to advise the consequences for each tree. So I'll just show some pictures of, and then the important thing is documentation, monitoring compliance, monitoring tree health, if we need to, doing some corrective measures. And then for some examples of projects, again, these are just, I showed this many years ago in a TCIA presentation, and someone said, that's more orange fence I've ever seen in my life. And these were like 2 projects we were working on, or 5 projects or 10 projects. But the idea is that you value that and you put it in. You can see the fencing outside, and we did a root crown excavation after the project started to make sure this large walnut tree was worth retaining. And fortunately it was. And I showed you this earlier. This is not tree protection or preservation. This is tree removal avoidance. So the idea is that the right trees can be selected and conserved during construction. The arborist needs to be involved in the process as early as possible and be a partner in the process and not the bad guy. When we get brought in at the end of the process, when things are already bad and we start being critical, we shouldn't have done this, we shouldn't have done that, we're the bad guys. We're not the bad guys. We're the only ones there that are speaking for the trees. Retaining large trees provides continuous ecosystem services to the site and communities. And that's what we're trying to do. We're trying to save these trees that are valuable assets to the communities. And the management standards and BMPs support what we're doing in our work, so it's not just the crazy arborist. If we can let the engineers and other designers and architects know we have these standards and help them, then it's going to help us allow sites to be kept where all these nice trees can be part of our community. This was downtown Redwood City, and the trees were very much a big part of the community. Conserving mature trees is a great return on investment. Trees can be developed around with reasonable foresight and protection. So we just have to make sure that we're planning ahead, being reasonable, and protecting as much as possible. And we want to use the standards and BMPs to write quality specifications. and then the specifications guide the work, but we still have to inspect to make sure that what the specifications say is actually being followed. And if we do that, then we have a very good opportunity that we're going to protect more trees on our sites. So here's my contact information. And I don't know if I'm supposed to give it right now or not, the CEU code. If I'm not, I can move that. And then if you get this program from me, I have a whole thing about alternative sidewalks that I presented at the Western chapter, and talks about the ideas, a lot of the infrastructure stuff we talked about. This one here, we moved concrete over a lot in Redwood City. In this one, the closest tree, we moved it away from the tree. Then right behind it, we moved it to the curb so we could plant a tree behind it. And farther up behind the light pole, we moved both the sidewalk and the curb out. So with that, I'm available for questions, and unless Fred has something else I need to do.
Oh, you're doing great. Let's see. If you got a question, just throw it in the chat box, and we'll try to get it out there. What do your root pruning operations look like? Are you air spading then pruning? Is the diameter limit to how large a root can be cut while maintaining tree health and structural integrity?
Okay, so when we did the sidewalk repair in Redwood City, if we were to air spade every tree we worked on, we wouldn't get any sidewalks done. So we root cut first, and then we inspected the root pruning afterwards to see if we were going to cause a tree instability. And if we were really concerned, we did a pull test on the tree to make sure it wasn't going to come over. And there were a few times where we did have to take trees down after we root pruned. But from my regard with the project, when I cut the trees down first, people said, oh, just put the sidewalk in straight now. There's no tree there. But I wanted to move the sidewalk over 3 feet anyhow to create space for the new tree. So for me, that whole thing worked out. When I'm on construction sites, usually it's either working with a pneumatic tool, like an air spade or an air knife, or there's now a lot more availability to these hydraulic vacuum excavation tools where they spray high pressure water and vacuum it away. And I find that works better than the air tools, especially when you're in a very tight situation or a downtown area where the dust would just be miserable to try and contain. And so we do look at those. And then just like pruning, I think you have to base the root pruning on the amount of roots that are there, the size of the tree. So it's nice to say don't cut any roots over 2 inches, but then you might not be able to, again, make the site work. And so when we do have the opportunity to do the full excavations, the root crown excavations, and look at the roots, we can look at, are the roots healthy? Do they have decay in them? And then how much pruning we can actually do based on the size of the tree and the root plate. For easy measuring, you can look at what they do when they move big trees. And they're usually anywhere from 8 inches to, I guess, 1.5 feet per trunk diameter for when they create their boxes for root pruning in order to move the trees. And so you can look at those for the size of what we want to try and do. But again, if you're only root pruning on one side of the tree compared to 2, 3, or 4 sides of the tree, as long as we're not impacting stability too much, we can get away with more root pruning. When you're root pruning on all 4 sides of the tree, then you have to get it as far away as possible, or your root plate won't be large enough to sustain the tree. If that didn't answer it, follow up with me.
After root pruning, do you fertilize in any way, such as the bonsai trees are done?
Yeah. So I don't know exactly how they do the fertilization on bonsai trees, but bonsai trees are pruned regularly, where they're picked up in the container and the roots are pruned the same as the branches are pruned. It's very intensive. I don't usually fertilize unless the soil test shows it. And when we do our root pruning, we're expecting root regrowth, and a lot of times the salts and fertilizer can be toxic to young tree roots. So I don't know that that's necessarily needed. And if we do a better job of soil remediation and aerated backfill, A lot of times we may not have to fertilize. There are some products out there, one I do sell called Mitagrow and other things like that, that are the root tip initiators. It's the auxins that develop new root tip growth. It's not a fertilizer, although they've changed the new Mitagrow, they changed the composition of it, and it does have a little bit of fertilizer and mycorrhizae in there. And I'm not convinced you can bring mycorrhizae in out of a box and have it work for a tree. So I don't recommend it as much as I used to when it was just the auxins that stimulate new root growth, because I have seen great benefits of it stimulating root growth, and it's not a fertilizer. So if you can find something like that, I think that's a better tool than a fertilizer.
So is the rule of thumb not to prune more than 20% of a tree's roots to avoid tree failure still accurate?
I don't think 20% is a number. I think it's closer to 35 or 40% for failure. And again, again, using a number like that, if you were to take concentric circles, and if a tree is, say the roots are 2.5 times a tree, I guess it's about 1.7 was one study I saw, that the root system is 1.7 times the crown drip line or diameter. And so, you could take 30 or 40% of all the fine roots out just by coming back to the drip line. When we use the drip line, we don't know how many of the root system we removed. I think you have to look at it from stability. And when it comes to risk assessment, I mean, I look at trees that have hollow trunks but have 4 or 5 sturdy roots, and I call them like stool trees, because the roots are soundly attached to the trunk, and even though the trunk is decayed, the tree is not going to fail at that point. If there's no decay that's critical further in the stem, those trees will grow for a long period of time. And I know tomorrow, Jeremy Barrow's doing a talk on ASCA about tree risk and older trees. And the whole thing is with track and trace, we don't just want to have something to check a box and say the tree is going to fail, so we got to cut it down. The whole thing about tree risk, the whole thing about our inspections as arborist is, what is the mitigation to retain the tree? The number one mitigation we have for crowns is pruning, not removal. We mitigate way more trees across the world by pruning than we do through removal. Removal is like the harshest mitigation. And the same with root pruning. We have to root prune in a lot of cases because we're putting things people want where trees are growing. And so we have to figure out that we do have to root prune. And so how much of it? So again, I don't try and use a figure. And again, it's on which side of the tree. If we're only doing one side, we can get a little bit closer. If we're doing more than one side, we may have to stay a little farther. Prevailing winds comes in, size of the crown, any protections the tree has from a big building we're putting next to it, or things like that. So there's a lot of considerations. I think if you were to stay with third as a basic starting point, it'd probably be okay. And then you can look at if you have to go more and what would be the impacts if I went more. And if I go less, then I think the stability should be fine. And then I just got to look at, is there any impacts to health?
Great. One last question, and I'll let you go. In your experience over your career, do you have any suggestions for pushback when moving a sidewalk, since you're building on people's property? Or any suggestions for when you need to move that sidewalk onto private property?
Yeah, so I think the three things that are important, and when you get in, if you're able to look at my presentation where I talk about the alternative sidewalk, and it's a brief one, not the full-on one. When you look at this, again, trees are dynamic and the sidewalks are static. The sidewalk can be replaced in 3 days, often less, and the trees will take 30, 40 years to get there. When we start looking at the benefits the trees have. So I think we have, first of all, it's what is the cause of the sidewalk damage, or is it just a new design? If it's a new design, we want to create the design for the mature size of the tree. The permanent sidewalk should be that far away, and then we can fill in anything between the permanent sidewalk and the tree with some kind of either modular or temporary or surface that we can use the site, but is going to be changed out to the permanent site. That part, the permanent place is not going to change as the tree gets bigger, but all the stuff modular and temporary inside can change. Then when we look at the value the importance of the trees, and then we look at the sidewalk. So if we can use something besides concrete, because we're in that area that's in that dynamic stage, there's in the, you know, I have probably 12 different materials you can use in there, and they've been used. It's not like this only my harebrained idea. They've been used other places. One of the products I sell is a plastic sidewalk, and it's finally being manufactured again after 4 years. And if I didn't keep the company in business, they wouldn't be around right now, because I had to go back to Indiana and help them get the manufacture going. But you need a product that is going to be a good walking surface, permeable, and not require 8 to 12 inches of compaction and root removal in order to have trees nearby. When we moved our sidewalks over on people's property in Redwood City, we did it with a easement. It was a sidewalk maintenance easement. So people fear government all the time. Apparently it's happening even more and more right now than it used to. So when you have to move a sidewalk over, you show the people that, first of all, this is only a sidewalk maintenance easement. It's only for us to move the sidewalk onto your property. It's going to allow us to keep the tree. The three things it's going to do is, it's not going to change your ownership. If the city buys that property from you, it now changes setback, however far we move it over. So if you have an existing house there with a porch, well, now your porch is in the setback, you have to remove it. Or if you want to put a new porch out in the future with the setback being moved, it's going to limit your ability to do that. From a budget standpoint, even though the city is paying for the money, as the homeowner, I'm still paying it, because my taxes and everything I do are what the city's spending on this. So if there's a way to do it less expensive, I can fix more sidewalks throughout the city, make the sidewalk static infrastructure safer, and do more of it by working with you on the easement. And then lastly, if the city does take the cost to do all the documentation like we did in Redwood City for the easement, it's anywhere from $150 to $300 a site to allow the movement, and the prices may change depending on attorneys and costs like that. But the hardest part we had about doing the easements was getting signatures from people. I had the city clerk out there with me walking house to house, and, oh, my husband lives in Nebraska. Oh, my wife, she moved to Southern California, and they're still on the title. So trying to get some of the signatures to allow the easement to be held is fine. But then again, on the other half of it, as long as the person owning the house knows the easement is there, if they don't declare it when they sell the house, that's a lack of disclosure. So it's not as much on the city, even though we want to have our ducks in a row and all our documents set. But I would have moved the sidewalk 5 feet or 6 feet over if I could have. My worst site was a engineer on, and he was a mechanical engineer, I think, on disability. And when I went to look at his site, he had like 25 printed pages from the ISA website about how we shouldn't hurt the roots on his Modesto ash tree. And so I said, oh, great. So instead of moving it 3 feet over, you let me move it 5 feet over, right? He goes, no, I want the sidewalk right back where it is. I go, well, again, you're an engineer, you're a bright guy. How can you expect me to do what you want me to do and not do what you don't want me to do? Because physics says two things can't occupy the same place at the same time. So in his site, we were able to come up with the rubber sidewalk product at the time. That was in 2003 or 4. And we were able to put rubber sidewalks down. And we also used asphalt sidewalks. And again, we considered them temporary, that they were being put down next to the tree until our permanent sidewalk got replaced. But the rubber wasn't temporary. The asphalt was the only temporary thing we did. We put the asphalt down until we could use a different treatment, either interlocking pavers. We weren't going to use concrete because we were saying we weren't doing concrete. So it was interlocking pavers, rubber, plastic, poured in place rubber, something. But we put asphalt down temporarily to keep the sidewalk safe, and then we'd move on so we could finish the street, check it off as being sidewalk managed. But I think, you know, a lot of it's based on the community. But if you have either elected officials or mayor, the most proactive city I've ever been involved with was my friend Craig Lundeen. Was he owned the art. He actually bought the tree company from John Britton, Tree Sculptors. And John was famous in the Western chapter, helped write our pruning specifications, helped get A300 started with pruning standards. So Craig, living in Piedmont, which is donut hole inside of Oakland, he he became the Parks and Rec commissioner, and he only did high-end pruning, and so he didn't even bid on the city trees, but he wrote the specifications for the city trees. And then after he was park commissioner for 2 terms or something, he got on the city council, and it was, well, you know, gee, Craig, now you got to be mayor. Well, you know, once he was mayor, he brought his city manager and his public works director into Redwood City, and we sat down at City Hall and had a conversation about what urban forestry programs need to be and what an inventory is. And I was able to explain to these people that had no clue what was going on, what needed to happen. And during his term as mayor in 2 years, they had a 4-year pruning cycle that continued on for over 8 years that I know of. And they had tree inventory taken care of during his time as mayor. So, I mean, if you really want to get something done, you can be mayor. But if you don't want to get something done, I'm sorry, if you don't want to be mayor and get something done, in Redwood City, I had a woman working our data entry for our tree inventory program because most of our stuff was on paper and we're trying to get the backlog into the inventory. And she came in one day and said, "Oh, gee, Gordon, I don't think I can do the inventory anymore." And the way she said it was like, "Oh my God, Jane, are you dying of cancer?" She goes, "Oh no, my the mayor asked Jack and I to start a tree planting nonprofit." So I went and worked with them on starting the tree planting nonprofit, City Trees in Redwood City, now going on 20 years, a very successful nonprofit program. And so she wasn't mayor and Jack wasn't mayor, but they knew the mayor. So as long as we're friends with these elected officials, they're influential with the elected officials, we can make things happen. I was very conversive with one of our council members, and he said, "Gordon, how come the sidewalk repairs program is going so slow?" I said, "Well, Ira, you know, what was my budget for the last several years?" And he kind of, you know, gave me the deer in the headlight look. "Well, don't look it up. I'll tell you. It's supposed to be 600,000 a year. It was 300, 500, 200, and let go, and then 500 again. And the one year it was 500, you used that money for the downtown sidewalk. Shouldn't even let me use it in my program." And you go, "Oh," I said, "So, you know, if you want me to do the program, you got to give me some money." And he said, "Well, what would happen if I gave you $1 million?" And I explained to him exactly how I'd use the money. And what he did was he said, "Well, we're going to do at least 1 year, maybe 2 of 750,000. And after that, we'll get up to $1 million." So we had 2 years of 750,000, then 2007 and 8 hit with all the housing shortages, and that's where the budget finally got cut again. But, you know, in 2004, my pruning budget went from 380,000 to 220,000. At the same time, our pruning bid went up from $94.50 to $145 an hour. I was getting squeezed at both ends. So, you know, how do we deal with that? Well, we wrote our pruning standards, and most of the trees that were on our list to be pruned met the standards, so we just took them off. It was the first time in about 20 years that we actually caught up with our pruning requests because we were able to change the standard and take most of the pruning off. And the trees were still risk managed, it's just they weren't aesthetics managed. So I think as, you know, as urban tree managers and community tree managers, for those of you in rural areas like I am, you know, there's a lot of things we can do. And I'm always amazed at how I get brought in as a consultant for all the things I did when I was a